So this is just a quick video to show what I've been up to. So to anybody that hasn't been following me on Patreon, which is like the vast majority because I've only got about 2 people on there, for the start of this year, I've actually been kind of putting together a game design document and kind of also developing a main character, creating the model and everything. And I've been putting that all onto Patreon for paid users, and I've also done like 1 or 2 free updates because there's a few people that are like following me there for free. I'm probably going to do more free updates in the future, but like if you are interested to see where this is going and what I'm up to, you can go over to Patreon and follow me there as well. So I'm probably going to try and upload more videos going forward, because now I'm actually getting into like the game development side of it. When the character's finished, then I will show that more. But for now, I'm actually like moving more into like developing the game and kind of showing what I'm up to. So what I've got here is something that I've been working on for about a week. This is actually a proof of concept, like, because there was a certain specific feature that I wanted to put in this game. This is probably like the most complicated feature that I wanted to put in the game. Everything else seems very easy to do. Like, I reckon I'd be able to do it in Unreal with just a bit of time and like learning and stuff. So I wanted to test this out and see if I could do it in Unreal, and if I could do it in Unreal, that would then determine if I'm going to use Unreal or Unity, because this feature I could easily put into Unity. There's also assets out there for Unity that already do this, and probably do it better than what I'm doing it here in Unreal. But this is like, this took a lot of trial and error, and me also trying a lot of different methods and doing a lot of reading up on stuff. But I eventually got it to work in the way that I want it to work. So I guess I'll show what I've been doing here. So the character here has no animations. They've just got a movement. And you've got this little white square which determines where we can aim and point and, like, in a way, shoot. It's not overly complicated. But over here we've got 3 badly textured models, which are just models that I've bought in through Blender. The reason I bought them in from Blender and not use like Unreal's inbuilt shapes is because their UVs in Blender are unwrapped in a very specific way so that the like UV faces don't overlap. So in Unreal, like a box, each face, they all occupy the same UV space. So if you texture one side of the box, it textures all sides of the boxes. All sides of the boxes? All sides of the box. Whereas here, if you texture the front face, you can texture the front face and the side face, top face. You can do them all individually because they all occupy different places on the UV map. You'll see that in a minute, like when I demonstrate how this works. You'll like also with the cone here, you see that it's all stretched. That's because it's basically 2 circles side by side. I haven't bothered to unwrap the cone better. I just used like what Blender had already there. But if I were to unwrap the cone, I would actually put a seam down the side here and make this more like this wrap here, like a square. And that would get rid of all this weird like warping and artifacting. But it's just here for demonstration. What we can basically do with this system is, I'll do it on this bright face so you can see a little bit better. If I click, I create a circle. If I click here, create another circle. If I switch our brush, we've got now a green one. And you'll notice that this box here, and these are 2 separate boxes, right? There's a seam here. And you can kind of see the seam on the texture there a little bit. When we go really close, there's a bit of a seam there, but they actually paint quite seamlessly, these shapes. Now if you paint on the corner, it's the same. It will go wrap around, and then here we've got like a smaller box. These are 2 boxes that are the same, except for this one is like 2.5 scale, so the resolution is different. Well, it's not the resolution of the textures is the same, but they appear different in world space because this texture is more stretched out because it's occupying a bigger space. But even if we paint here, it paints perfectly fine. So what you might be thinking is, oh, well, you're just using decals. which is not what I'm doing at all. I'm actually painting on a texture to be able to do this, and you can see along the edges of this circle here, on the left hand side it's a little bit more blurred, whereas on the right side it's a little bit more sharp along the edges. That's because in theory this circle would actually be like more like this, like a big circle, like if it were translated one-to-one to this. But with this method that I'm doing, it doesn't matter the size. The brush size will always be consistent no matter what size of the object and what resolution of the object. What it also allows with this system is I can actually set the resolution separately per object. So if I've got a small object that I need a smaller kind of resolution to, like a smaller paint resolution because it's a smaller object, I can set that up. And if there's like a big building, I can also have it have a bigger resolution to basically keep the paint still sharp, like along the edges mostly, because the inner side of the texture, it uses a world space thing, and I'll show all that in a minute. That's how that texture, like the actual texture that you can see, is always consistent. And then, like I said, we've got 3 channels, and we can also erase like this, and just erase everything, right? It also works on the cone, so again the shape remains the same, even though this is all stretched out, which, to be honest, the fact that the cone is stretched out is good, because we can kind of still demonstrate how this texture still remains fairly unstretched. It does stretch and warp a little bit, but it, like, the shape and everything remains. Now, I went through 3 methods to do this. The first method is a method you'll find on YouTube quite easily, which is when you shoot out a ray and hit the position, you get the vertex, the UV, sorry. You get the UV position, and then you can paint something into something that's called a render target, which is essentially like a texture that you can paint into at runtime. Render targets can be used for lots of things. You can use them for, like, say if you're wading through snow and you want, like, the snow to kind of like compress around your character. You can do it for something like that. You can also use it for, like, say if you were to put a boat in water and you want, when you're inside the boat, to not have the water kind of like clipping through the boat, you can use render targets for that. There's loads of uses for them. The problem with the first method is when you paint on a corner like this, it won't paint around, because it's not painting a volume. It's painting almost like it's finding the location on the texture, and then it's just printing, like stamping a shape there. So the benefits of that is you can have any shape you want, right? You can bring in a texture and you can print a smiley face on a wall, which is ideal if you just want a whiteboard. But if you want to be able to paint on the environment, like in 3D, no matter the shape, like even if this was like a person, I'd be able to paint on them. And the other thing about this is this will also work on animated figures. So if you've got a character walking, you can paint on them, like no problem with this method. Because you're shooting at a ray and hitting a specific point, you'll also find when you come to paint on 2 objects like this, it would only paint on the object that you hit and not on the object next to it. And you wouldn't be able to offset it. So if I were to paint like here, see the seams here, but we've got like this kind of little bit of the circle, you wouldn't be able to offset it. It would always be fixed at the origin point of whatever you're painting. So it would always be like this. Like you wouldn't be able to paint like here and get like this kind of overlap. So that was like, it kind of did what I wanted, but I needed to be able to paint seamlessly on everything. And the other problem is like resolution and all those kind of issues. There's like so many other issues with it. And to be honest, it's not surprising considering how easy it was to set up. Again, you can go on YouTube and find, if that's what you're looking for, you can go on YouTube and find that solution very easily. Right, so this brings me on to the second one. So the second method that I found is kind of similar to the method that I'm doing here. And what it does is when you hit the object, you unwrap it. So you basically turn it for a split moment. It becomes like the UV unwrap, but in 3D space. So you unwrap it, and then it's just there in 3D space like a plane. I'll actually show this like properly in a second. And then what you then do is use a camera to capture it and then save it into the texture each time that you paint. I've got to explain a few more things because this method used 2 render targets. One would store all the vertex information, and then the other one would store the paint information. And you could paint on corners, but because it would use like the surface normals to like kind of calculate how to paint, what would end up happening is if I were to paint on a flat face like this, like here for example, this area wouldn't be curved. What it would do is it would paint all the way across in a big long smear, and then paint the same on the opposite side like that, right? So you imagine I'm painting here, you're just painting a massive line all the way across, and it would look ugly. And also you're using 2 render targets, so you're having an extra texture in there to store all this extra information. And if you imagine you've got a full environment with loads of these models in, then you've got a problem because each like model then has multiple textures assigned to them. So you then like your memory budget is gonna be like through the roof because you've got to store all these like textures somehow. Whereas with this method, this does a similar thing, except that it only uses 1 render target and it uses 2 materials, whereas the other method would use 2 render targets and 3 materials. The 3 materials would be the material that's on the object, then it would have an unwrapped material that it will briefly switch to, so then it could capture it with the camera, and then you would also then have a brush texture which allows you to select your shapes and stuff. And then the 2 render targets, one to store all the vertex information and then the other one to store the paint information. Whereas what I'm doing is I'm using 1 render target that stores the paint information, and then I'm having 1 material which is what you can see here that's presented on the object, and then the second material is a unwrapped material that is briefly set to take a picture of it. Right, so I'll try and demonstrate this now. So I've disabled part of the code here so then we can see what happens. So when we shoot something, we hit it, and then all of a sudden it unwraps. So what it's done is it's switched to a different material. And this red dot here is the location where we just hit. And the reason it's red is because if I were to change my my brush color, we're now painting green and then blue, and then the last one that is clear will just be black, so you can't see anything on here. We can still see that we're hitting the cube in 3D space, right? That's what this little pink line is. But each time it's like updating on the material, right? So say if I were to hit dead center in the front here, it would occupy this square here, which is the center square. This would be like this face of the box here. So what the camera's then basically doing is the camera's up here looking down at it, and the camera's set to orthographic, which means there's no depth. So it will create, like, no matter the distance away from an object, it will also always create a flat picture at the same size, and the size is determined by the orthographic the size is determined by the FOV of that camera. This is like the model. If we were to bring this down, there's the camera in there inside it, right? And if we go to the scene capture, it's orthographic and it's got an author width of 512, which is the texture size. So this could be put up to 4K, or it could be put up to like 424 or whatever. You can also put it as low as 52 or whatever, like whatever you want, 64, whatever number, right? It will scale it equivalently, right? So if I go back in quickly and paint again, you'll see now that it's a tiny texture, it's like a little cross in space, right? I accidentally hit that one. If we do this one here, you'll see that it's 2 circles, right? And you can see like the circle on it's like all warped and rounded, right? Again, because this is the same resolution size, it's the same size as this cross here now. So now what I've done is I've introduced the capture into there. So each time now, the capture will update the render target. So it's updating the texture each time. So you'll see now we're actually getting, I'm going to put the resolution back up in a minute, but you can see it's updating each time we paint on it. Even though the resolution's now set at like 52, we can still paint on it and we still get like a actual texture. What happens is the edges become more blurred, which actually something that in demonstrating this gave me an idea for another feature that I'll show later on, like a better implementation than what I'm already doing by using this method. So yeah, so now we're painting a circle. So I'll just briefly show the material and see how this kind of works. So down here we've got this unwraps it and goes into the world position. Then over here we've got excluding material offsets. So that means this is creating a material offset here, right? And we want to use the original model's position. And then what we do is we have a hit location which is passed in, which is when the ray hits, it gives us a hit location. We pass this into a sphere mask. So by using the world position, and I mean, if you ignore this add and all this is something I'll show in a minute, and ignore this add, basically this would just be plugged in and this will be plugged in into the sphere mask. And then we got the brush radius, which determines how big it is. The hardness, you can change this to make the edges more smooth as well. This is what the sphere mask is. This little circle here that we're getting, this is what the sphere mask is doing. But what I'm also doing is at the hit location, I'm collecting all meshes in this region that are hit, right? And then I'm passing in that location to all of their shaders and updating it. And then that camera is then capturing that information and then saving it into the render target. And then next time when we paint again, it's doing the same thing again and again and again. And again, so we're painting red, then we're painting green, and then we're painting blue, right? So then you end up with then a texture that has red, green, and blue dots all over it. And then from there, we can go into here, and this will be the actual material of the model, which is that brick texture, right? So imagine this is the brick, right? Using absolute world position, so this texture will tile seamlessly across the entire world. We then input these 3 textures, which then are applied to here using the render target, which I can't. Oh, the render target's here. So this is the painted layers with all the colors on. This is all split out, and it's also used as a mask to then mask over the existing material that's there. So the beauty of this is we can input in here a lot more manipulation to the UVs and of these textures to make them look like we can make like this water actually look like water. You can have it shine and have it shimmer and move, so then it looks like a puddle. And then this one we could make it so, for example, if this was like a slimy substance, we could do the same with that, and then this could be, I don't know, lava or something, right? So we can do all this, but the problem is we've only got 3 channels that we can work with because we've only got RGB. Now if we want to increase the number, we have to now introduce more render targets, which results in more textures. For what I want to do, I only wanted to use like probably 2 or 3. But I also want to be able to have different colors. So like this slime color, this slime texture, I might want to have different color variants. So what I would do to make that work is I would introduce a second render target, which is captured at the same time, which holds color information. And then that color information is then applied to this through like a more advanced shader. And then that is all then rendered. So yeah, that's how this all becomes so seamless, because this is using an absolute world position in this thing. So the limitation of this. So obviously the limitation is we can only paint a sphere. We can only paint these circles, which is no good if you want to have like an actual shape to it and make it look like something else. Now the problem is I couldn't work out how to like import a texture for the sphere mask to make it the shape that I wanted. However, I did find a way to manipulate the sphere mask using noise to more represent like a paint splatter. Back here we've got like this kind of noise texture which is tiled, because I'm using world space, I've tiled it like really high up to kind of give like kind of a general scalar value across the entire world for this particular noise. And then what I've done here is I've got a splatter value that I multiply it by, which is between 150 and 75. I generally put it at 75 because I think that produces the best results, but if I put it up to 150 it will splatter it a little bit more because of this distortion. What this like texture basically is like it's like greens, reds. It's like basically like noise clouds all layered on top of each other, which is like a RGB kind of different, like layered on top of each other to kind of create this kind of funky look. And then this is just got a time value where it's slightly moving over time. What I'm probably going to do in the future is change this time for like a random value that's done through code, but I'm just using time at the moment so I can get some kind of randomness to it. And then this is then like added to the sphere, like to the sphere mask, to the world position, and then applied to the sphere mask. So I can kind of show what this looks like. How this is, if I take this out, you can actually see on the unwrapped version what this looks like. See how it's like a flamey looking kind of thing going on. So if I replug that back in now, right, so this is where we're at now. So we can now actually paint shapes. So I can't specify the shape, I can only kind of auto-generate it. But for what I want to do, really, this is good enough, because I want some kind of randomness to these splatters, because they're basically going to be like water and like slime, lava, whatever, right? I then started going into another avenue and trying to work out how I could make this a little bit more dynamic. So I had two ideas in mind. The first one was water. Like if you put water on a wall, you would want it to run down the wall, right? No matter how hard I tried, I couldn't get this to work, because the issue you've got to try and factor in is when we paint here, we want it to travel downward in world space at a set interval. So no matter the resolution we paint it on, it will always move at the same speed. And I couldn't for the life of me work out how to do that. And then the other issue is when you unwrap a model, the direction of the faces are always going to be different. So X is this way and then like Y is down this way, right? Depending on how the model's been unwrapped, this will change. So what you'd have to do is every model you'd have to UV unwrap them in a way where it's consistent, where Y is always they're always rotated in a way that it would always go downward, right? Because you can see at the moment this brick texture is like rotated to the side, and that's because of the way it's been unwrapped. If you wanted to kind of move the UVs to make the water run down the wall, you would have to know that information. I mean, I managed to get it so if you were to paint on the floor, I mean the floor's not set up, the floor wouldn't run, but the walls would run by masking everything. I managed to get that to work. And I got rid of the material in the end because there was too many like glaring issues with it that I couldn't make it consistent and make it something that would be workable. The alternative I have would be when we hit here and paint, the world position in code just moves down like this, right? So you'd hit a wall and it would just like that. Like for a few frames it would just go blur, right? And then if you combine that idea with another idea that I've got, which I actually kind of got working, the method of which I've done it creates artifacts, so I'll show that off so you can actually see. What does water do when it's in the sun? Water dries. And originally I had it so when you painted it onto a wall, over time it would just fade out, which isn't really how puddles dry. Like a puddle doesn't like just fade out. It kind of like shrinks until it's like a small bit of water, and then eventually it disappears, right? So like it kind of like evaporates from around the edge, because obviously water like tends to like congregate at the lowest point, so it would have to shrink. So this is what I've achieved here, right? So as you can see, it shrinks. It will stop at a certain point because I've got like a time limit of how long it runs for. So it's stopped now. But I can make that run for as long as I want. The first method I tried was with mipmaps. So with mipmaps, if you set the mipmap level up, you can get like a blurred version of a texture. And then what I tried to do then was then clip like those blurred edges. So then you get a smaller like mask, and then apply that mask so then like you can kind of cut away the edges of that shape. I will actually just show, like if I were to do this, for example, right? This only works on one channel. So the water evaporates, but the slime does not, right? And then it leaves behind a black space. So this is like working exactly how I want it in a way. But there is an issue, whereas if I paint a big area, we get this artifacting, right? And that's like, you basically got the texture, like the mask for what we've painted, and you've got it 4 times, and they're offset by like a pixel in every single direction, and then like kind of like a little bit of maths done so that we end up cutting away, like basically creating like an edge from the texture. And that's why you get this like kind of diamond shape occurring, is because of the direct, it's only like cutting away in 4 directions, so it ends up creating these just like ugly looking shapes, which is not really ideal for what I want to achieve. The other method that I used was using a spiral blur, which is actually very expensive, and if you're like having that run on every single like model in the like every model in the area, it's going to be costly. So that idea was kind of out the window. It was unfortunate that the mipmap version wouldn't work, because that would have been the ideal solution. I haven't implemented it yet, but I have an idea. Earlier that I showed you that you could change the resolution. So you know, like earlier I changed the orthographic size down to like 52. So I ended up with like these textures that have like a really blurred edge, right? So the other solution I have to make this work is basically change the orthographic size so it's small, recapture the image, and then clip the edges. And then keep doing that over and over and over, so each time it's getting smaller and smaller and smaller. It could in theory work, but it's going to take a lot of messing around to get to work. So yeah, the theory for that is there. I would have to like try and work out how to do it, but I'm not sure if it will work or not. But I'm kind of not going to pursue this anymore. I just wanted to see if I could actually get this to paint in the way that I wanted it. I mean, anything extra like this dissolving like this is like a bonus, and I'd also have to be careful of how I implement this in like a broader like context, because if you've got like a lot of textures that are running like a lot of models, sorry, that are running like an update. I mean, this has got a tick rate on it, which the tick rate's really small at the moment, but it's not every frame that this is getting reduced. It's like every like 0.1 of a second, but I could up that tick rate, because obviously the water's not going to dissolve this quickly. It's going to dissolve over like a longer period of time, and like in the game context, if you walk away from it by a certain distance, then I can delete all the textures that are there because they're not needed anymore, and I can stop these things from running. They'd only happen like within a local area to kind of optimize things a little bit better. Again, so the whole like, if I were to use like a blurred version of the texture, lower resolution capture, I could have that as a really low resolution so it doesn't take up a lot of texture memory, so I can still apply a blur for pretty cheap. Whereas again, if you're using a spiral blur, it's expensive. If you're like overlaying the texture multiple times, it's probably a bit cheaper, but you have this artifacting where it's like makes these weird diamond shapes in the texture, which is like again no good. So I reckon that solution might be the avenue that I go down, but I'm not going to be doing that because we're going to move on. We're going to start like actually making the game. I just wanted to see if this would actually work, and I'm actually surprised I managed to get it to work in the way that it does. So if like say an explosion went off and it was like a slime explosion, it would cover all the walls. And what I could tie this into is, say if we've got a particle system, I could tie it into particle system as well. So then like when the particles collide with surfaces, they leave behind splatters and all that kind of stuff, right? I could set all that up. All I wanted to see is if I could actually paint the texture and store it as a texture opposed to decals, because the other alternative was I could do this all with decals, right? I could paint loads of decals onto the wall, but then you just add in loads of decals, which are expensive when you've got a lot of them, and you can't overwrite. The kind of good thing about the multiple channel thing is we can actually overwrite and then like erase them and like get whatever shapes we want, and we're not limited to like a decal shape. I mean, like we could like just make whatever shape I want with what's here now. You know what I mean? Like that. Like these are just little bits of splatter now. So that's it. The other thing that this can be expanded out to is when you walk on certain surfaces, we can detect what color value is that pixel, right? So if you're walking over slime and you can detect that it's the green channel, we can then have certain things happen, like when you stepped in the green areas you take damage, or when you're stepped in the blue areas your movement is slightly different, or whatever, right? So all these things are possible. There's a lot of possibilities with this, and the fact that I've got it working is like quite surprising. I really thought I wasn't going to be able to do it, and I thought I was going to have to resolve to like a method in Unity. If anybody's interested in a Unity version, I have got like a write-up somewhere, that like a link to a full write-up that somebody did that basically does all this stuff. It kind of works in a similar way, but kind of not at the same time. I had to kind of, for Unreal, I had to kind of come up with a whole other way of doing it. And to be honest, I'm not the most like clever when it comes to programming. I'm like decent, but when it comes to stuff like vector math and all this kind of crazy shit, I'm just really terrible at it. The fact that somebody as stupid as me managed to get this working is actually quite surprising. So yeah, that kind of concludes it. I don't know if there's anything I've missed. I think that's about it. I'm not going to go into a full demonstration of this and kind of really go into the nitty-gritty. I kind of, if people want to be able to achieve this, I can point them in, like, show them the videos that I watched. I can show them, like, the documentation. There were 2 tutorials that I followed, and I ended up, like, mixing a few methods together to try and get this to work. And then I just experimented for, like, about a week to try and get, like, it to work in the way that I wanted. So if you are interested in trying to achieve this, then I will send you, like, all the links or something. Maybe, like, if there's anybody that shows interest, I'll put them in a pinned comment or something, whatever. But yeah, for now, that's it. And that's kind of the end of the video. So would you kindly bugger off?